Harium. We have seen moving coil, galvanometer and those details, and we understood that galvanometer is just a detecting instrument and it is not a measuring instrument. Now, how we can use that galvanometer to measure current? I mean, into an ammeter so that you can measure the current flowing through a circuit. That's what we are going to see in this one. So, ammeter is basically a very low resistance device that ideal ammeter will be having zero resistance. So, to convert a galvanometer into an ammeter, what we are doing is, I have a galvanometer and I connect a very small resistance parallel to the galvanometer. So just by connecting a very small resistance parallel to the galvanometer, the whole system acts as a ammeter now. And connecting a very small resistance in parallel, we call it as shunting. And the resistance so connected here is called shunt resistance, and I have taken it as S here. So suppose that I want to measure a current I, the maximum. If I allow this current straight into the galvanometer, what happens is that this galvanometer cannot withstand that current and it is spoiled. So, what I do is, I connect a very small resistance in parallel, then the current coming here will be dividing and allow the current Ig through this one. Ig is called galvanometer current. That means it is the maximum current that is allowed through the galvanometer without spoiling it. And the remaining current I minus Ig will be flowing through the shunt resistance as per Kirchhoff's first rule, and it reaches here and flows out as I. But in between, as the splitting takes place, this galvanometer is getting calibrated to act as an ammeter. Okay? So how much is the shunt to be connected? That depends on the current that is to be measured using the galvanometer. If I is the maximum current to be measured using the galvanometer, then you can say that from this Ig into Rg, where Rg is the resistance of the galvanometer. Rg is the resistance of the galvanometer. Then Ig into Rg will be equal to I minus Ig into S. Parallel combination of resistances. Drop across galvanometer will be equal to drop across the shunt resistance. And from this you can see that shunt resistance to be connected will be equal to Ig into Rg divided by I minus Ig. So using this particular formula, you can find the shunt to be connected. That depends on the range of the current to be measured. Okay? Now let us see how it is working. So I calculated the shunt and connected there that the current to be measured, let it be 10 ampere. It's an example. 10 ampere to be measured. And 2 ampere is allowed through the galvanometer, the maximum. Then definitely the shunt resistance will be sending 8 ampere current through it, right? So when Ig flows through this, galvanometer gives the maximum deflection. That is, galvanometer, the reading will be like this, 0, and the markings will be there like this, and when the Ig flows through this, it gives a deflection the maximum. Okay. So this is the maximum deflection, and that maximum deflection is for 2 ampere flowing through it. But you are connecting a current of or sending a current of 10 ampere. For that 10 ampere, you get the maximum deflection. So this I can take it as 10 ampere level now. Now what I do is, instead of sending 10 ampere, if I send 5 ampere through this, then what happens is that the ratio changes. 1 ampere flows through the galvanometer and 4 ampere flows through this as per the resistance ratio. Okay, then what happens is, it is now 1 ampere flowing through the galvanometer, so it has to give half deflection, right? So this is maximum, and now that will be showing the half of it. That means the galvanometer reading now 0 to the maximum. Now this is calibrated from 0 ampere to 10 ampere automatically. So this is how the galvanometer is getting calibrated to read 0 to 10 ampere. So it is not a galvanometer now. Together it is acting as a what? Ammeter. Alright? So this is a simple method to convert the galvanometer into an ammeter. So what is the resistance of the ammeter so obtained? Let us see. Resistance of the ammeter 1 by Ra, for ammeter, will be equal to 1 by Rg plus 1 by S. Okay? Because Ra is the resistance of the ammeter obtained. That will be now the parallel combination of Rg and S. From this one you can now calculate what is Ra. These are the basic things about the conversion of galvanometer into an ammeter. But one more point. Can we increase the range of the ammeter? Can we increase the range of the ammeter? Yes, definitely. This I can be increased. How? When this I increases, all these things are constant, therefore I increases, I minus Ig is increasing, thereby the shunt resistance goes on decreasing. So decreasing the value of shunt resistance, you can increase the range of the ammeter to be obtained. But the question can be worse. Like, can we decrease the range of the ammeter? Yes, up to an extent. Remember, if I go on decreasing the range, there is a level coming I equal to Ig, right? When it comes I is equal to Ig, what happens? The denominator becomes 0 and the shunt resistance, okay, becomes infinite. It is an open circuit now. And even further, if you go with reducing this value, you can see a negative sign will be coming here and the shunt resistance becomes negative. Negative resistance, not possible. Okay, so decreasing the range of the ammeter is possible up to a limit, but increasing we can do to a very large extent. Okay, these are the points to be noted.